Hello students, today I am presenting the component and working of simple vapor compression refrigeration system. So basically there are four components of this system, that is the compressor, condenser, expansion valve and the evaporator. So in case of four compressor, there are four processes are used in the VCR system. First process, that is 1 to 2, it is known as isentropic compression of saturated vapor in compressor. We can assume that point 1 it is the point 1 we can assume in the inlet of the compressor, and point 2 we can assume at outlet of the compressor. So there are 2 points for the inlet and outlet for the compressor, and the process 1 to 2, that is the isentropic compression of saturated vapor in compressor. For part 2 or component 2, that is inlet of the condenser, it is point 2, and the outlet of the condenser, it is known as point 3. So process 2 to 3, it is known as isobaric heat rejection in the condenser. And the for expansion device or expansion valve at the inlet, that is the point, it is point 3, and outlet of the expansion valve, it is known as point 4. So the process 3 to 4, it is known as isenthalpic expansion of saturated liquid in expansion device. And the last process or last process is used in the last component, that is the evaporator. In case of evaporator, the inlet point, it is known as point 4, and the outlet, that is the point 1. So process 4 to 1, that is the isobaric heat extraction in the evaporator. This cycle is very beneficial and it is used in refrigerator or air conditioner, that is domestic refrigerator or domestic air conditioners, with the industrial and commercial purpose also. So four component for the cycle, that is compressor, condenser, expansion valve and the evaporator. For condenser, it is known as high pressure side, and the for low pressure compressor, low pressure side for the evaporator. So the low, it is the high pressure side for condenser and it is the low pressure side for the evaporator. So there are two pressure range, that is the higher range and this is the lower range. So for vapor compressor refrigeration system, there are four component. First component, that is the vapor of at low pressure and low temperature enters the compressor from the evaporator, where it is compressed to high pressure and high temperature. This high pressure and temperature vapor refrigerant are discharged into the condenser through the discharge valve. And for condenser, the condenser consists of coils of pipe in which the high pressure and temperature vapor refrigerant are cooled and condensed. The refrigerant, while passing through the condenser, gives up its latent heat to surroundings condensing medium, which is normally air or water. And for expansion valve, it is also known as throttle valve. The process is throttling, that is the, and its function is to allow the liquid refrigerant under high pressure and temperature to pass through, where it is reduce the temperature and pressure. And for evaporator, it is the last component of the cycle. It is also consist of coils of pipe in which liquid vapor refrigerant at low pressure side and the temperature is evaporated and convert into the vapor refrigerant at low pressure and temperature. And this is the TS and PS diagram for the VCR. That is the this is the TS diagram, and you can see here, this is the dome, this is the uh, uh, liquid line, this is the dry saturated line for the TS diagram, and this is the liquid line for PS diagram, and this is the dry saturated line. So this is the, there are two domes for the respective for TS and PS diagram also, and this is the 1 to 2, it is known as isentropic compression for this VCR cycle. Process 2 to 3, this is the isobaric heat rejection process in the condenser. 3 to 4, there is the enthalpy is constant, so it is known as isenthalpic process, and the expansion due to the pressure is goes down. So 3 to 4 is isenthalpic expansion process, and 4 to 1, this is the in for evaporator, that is the pressure is constant and the heat is extracted or absorption in the evaporator. So it is known as isobaric heat absorption process for the pH and TS diagram respectively. So analysis of the standard vapor compression refrigeration system, that is the a simple analysis of standard vapor compression system by assuming some assumptions, that is the steady flow, negligible kinetic and potential energy change across these components, and no heat transfer in the connecting pipeline. So these are the assumptions. And for evaporator, heat transfer rate of evaporator or refrigeration capacity is given by that the heat is equal to mass flow rate of the refrigerant into enthalpy change, that is the H1 minus H1, that is the 1 and 4 is the respective points. So compressor, that is the power input the compressor, it is W for compressor, that is the mass flow rate for the refrigerant into enthalpy change, that is H2 minus H1. So these are the enthalpy change, and the MR is the mass for refrigerant. So this is the evaporator heat transfer rate at evaporator, and this is the compressor. So the COP of the system, you know, COP, that is the coefficient of the performance of the system or cycle, that is the refrigerating effect to the work input. So this is the MR into H1 minus HF3, or HF4 is equal to HF3, and to divide by MR into H2 minus H1. So MR is cancelled out. So finally it is H1 minus H4 or H3, that is to the H2 minus H1. So this is the final COP of the VCR cycle or system, and this is the references which are used in this slide, in these slides, and this is the references and this. So thank you.